Assalamualaikum and hello everyone. Welcome to my presentation video. My name is Alia Akila binti Budiman and I am a final year student in the Bachelor of Food Science and Technology with Honour at University Technology Mara UiTM. This video presents my final year project entitled Screening of Parameters Affecting the Physicochemical Properties of Almond Keto Bread, a Plackett Burman Design approach. The purpose of this video is to share the objective, methodology, key findings, and significance of my research. I hope this presentation provides a valuable insight into the development of Almond Keto Bread and demonstrate the application of design of experiments (DOE) in food product development. My presentation consists of introduction, problem statement, objective, literature review, materials and methodology, results and discussion, followed by conclusion and recommendation. Bread is one of the most widely consumed staple foods worldwide because it is an important source of carbohydrates and dietary fiber. However, conventional wheat bread has a relatively high glycemic index, which may contribute to elevated blood glucose levels. Therefore, there has been increasing interest in low carbohydrates alternative, especially among individuals following ketogenic or gluten-free diets. Since almond flour does not contain gluten, it cannot form the gluten network that normally traps carbon dioxide during the fermentation. As a result, keto bread often has a lower loaf volume, denser texture, and reduced consumer acceptance. One of the most common ingredients used in keto bread is almond flour because it is naturally gluten-free, rich in healthy fats, proteins, vitamins, and minerals, while containing fewer digestible carbohydrates. However, replacing wheat flour with almond flour creates another challenge. Because bread quality depends on many ingredients and processing variables, it is important to determine which parameters are truly significant instead of changing one factor at a time. Therefore, this study applied the Plackett-Burman design, which is an efficient screening design capable of evaluating many variables using only a limited number of experimental runs. The main problem is that almond keto bread generally has poor physicochemical properties such as dense texture, low loaf volume, and undesirable color, which reduce consumer acceptance. Although many studies have developed keto bread formulation, most focus on producing the final product rather than systematically identifying which ingredients and processing conditions significantly affect the bread quality. Therefore, there is still limited scientific information regarding the critical parameters affecting the almond keto bread. This study is significant because it provides scientific information on the important formulation and processing parameters affecting the almond keto bread quality. In addition, using Plackett-Burman design reduces unnecessary experiments, saving both time and resources. Finally, this study supports the Sustainable Development Goals, which are SDG 3, Good Health and Well-being, SDG 9, Industry, Innovation and Infrastructure, and SDG 12, Responsible Consumption and Productions. The objective of this research is first to screen the ingredients and processing parameters affecting the physicochemical properties of almond keto bread using Plackett-Burman design. And second is to evaluate the significance of the identified ingredients and processing parameters on the physicochemical properties of almond keto bread using analysis of variance (ANOVA). Previous studies reported that the ketogenic diet is characterized by low carbohydrates, high fat, and moderate protein intake, which shift the body's primary energy source from glucose to fat through a metabolic state known as ketosis. Among the various keto ingredients, almond flour is one of the most commonly used because it is rich in healthy fats, dietary fiber, and essential amino acids. These nutritional properties make almond flour a suitable ingredient for developing keto-friendly bakery products. Despite its nutritional benefits, previous studies have reported that keto bread generally has lower loaf volume, a denser texture, and different color compared to conventional wheat bread. These differences are mainly due to the absence of gluten, which is responsible for forming the elastic network that traps gas during fermentation. To evaluate the bread quality, researchers commonly measure physicochemical properties including low volume, pH, moisture content, water activity, texture, and color. These properties are important because they influence consumer acceptance, product quality, and shelf life. In food product development, response surface methodology (RSM) is widely used to optimize product formulations. However, optimization should only be carried out after the important variables have been identified. Therefore, Plackett Burman Design was selected for this study because it is specifically developed for the screening stage. It efficiently identifies the significant ingredients and processing parameters before optimization is performed in future studies. The physicochemical analysis performed included loaf volume, pH, moisture content, water activity, texture profile analysis, and color measurement. For the almond keto bread making, the first step is each ingredient was prepared according to the assigned experimental levels. The dry and wet ingredients were mixed separately before being combined in a bread maker to produce a uniform dough. The dough was then proofed according to the assigned proofing time before baking under the specified baking temperature and baking duration. After cooling, the bread samples were analyzed. A total of 24 experimental formulations were evaluated. The responses obtained from each formulation were entered into design expert software for statistical analysis. Each response was analyzed separately to identify the significant factors influencing that particular physicochemical properties. Several responses, including pH, moisture content, texture, and color, produced statistically significant models. However, many of these responses also showed significant dummy variables or significant lack of fit. Let's go through one by one. Although the pH model was statistically significant, it was not selected as a reliable screening response because significant dummy variables indicated unexplained experimental variation, reducing the confidence in the identified effects. The moisture content model was also excluded because it showed a significant lack of fit, indicating that the regression model did not adequately fit the experimental data. Both firmness and springiness were excluded from further discussion because their models showed significant lack of fit and did not satisfy the required model adequacy criteria. Therefore, they were not considered reliable screening responses. For crumb color, the L response was excluded because one or more experimental runs exceeded the recommended DF-beta's limit, indicating excessive influence on the regression model. Meanwhile, both A and B responses were excluded due to the significant dummy variables indicating insufficient model adequacy. Similarly, the crust L response was excluded because the DF-beta plot exceeded the recommended limit, suggesting that the model was influenced by a small number of observations. The A and B responses were also excluded because the models contain significant dummy variables, making them unsuitable as reliable screening. Since dummy variables should ideally remain insignificant, their significance suggests that unexplained experimental variation may still exist. Therefore, these responses were not selected as reliable screening responses despite having statistically significant models. This is an important point. A statistically significant model alone is insufficient. This screening response must also satisfy model adequacy criteria, particularly an insignificant lack of fit and insignificant dummy variables. Among all responses, low volume produced the strongest statistical model. The overall regression model was highly significant with a p-value less than 0.001. The model explained approximately 84.22% of the variation in low volume, and the lack of fit was not significant, indicating that the regression model adequately represented the experimental data. The Pareto chart showed that four parameters significantly influenced the low volume. Egg and baking temperature showed positive effects, means increasing these parameters tended to increase the low volume. The reason is that eggs contribute protein, which strengthen the bread structure and improve gas retention, while an appropriate baking temperature promotes oven spring before the crumb structure sets. Water activity also produced a statistically significant regression model with a p-value of 0.0010, indicating that the investigated factors significantly affected water activity. The model explained 55.07% of the variation in water activity. Although the R-squared value was lower than that of a low volume, the lack of fit was not significant, confirming that the regression model adequately fitted the experimental data. Furthermore, the model exhibited acceptable predictive performance for screening water activity. Three parameters were identified as significant. Cream cheese and baking temperature showed significant negative effects, whereas baking time showed a significant positive effects on water activity. The negative effects of baking temperature can be explained by greater moisture loss through evaporation at higher temperatures. In addition, cream cheese binds part of the available water within the bread matrix, reducing the amount of the free water available. In contrast, baking time showed a positive effect on water activity within the studied range, which may be attributed to moisture redistribution within the bread after baking. According to Marinin 2021, water activity is a critical quality parameter because it determines the availability of the free water for microbial growth, thereby influencing the safety, stability, and shelf life of bakery products. Therefore, based on the significant model, insignificant lack of feed, and acceptable predictive performance, water activity was accepted as a reliable screening response. In conclusion, 6 significant parameters affecting the almond keto bread quality were identified. Egg, baking temperature, yeast, and proofing time significantly influence the low volume. Meanwhile, baking time, cream cheese, and baking temperature significantly influence the water activity. These findings indicate that the low volume and water activity are the most reliable screening responses for identifying the critical ingredients and processing parameters in almond keto bread. For future work, the significant formulation and processing parameters identified in this study can be further optimized using a central composite design or CCD. In addition, sensory evaluation can be conducted to assess consumer acceptance, including the crumb softness, aroma, and overall preference. Finally, storage stability and shelf life study should be performed to evaluate the quality and stability of the optimized almond keto bread over time. This concludes my presentation. Thank you for your time and attention. I sincerely appreciate the opportunity to share my research with you. I hope this presentation has provided valuable insights into the screening of parameters affecting the physicochemical properties of almond keto bread using the Plackett Burman Design approach. Thank you.